Linear and Nonlinear Functions, Lesson 14 Worksheet, Question 22 and 23. Question number 22. Sam uses a function to determine the height of a football from the time it is kicked to the time it lands on the ground. Is the function linear or nonlinear? Use words, numbers, or models to justify your answer. We're going to actually use all three. Let's start with the model. Now, I know there are different ways to kick a football, all right? But even if it's a squib kick, even if it's a kick that just squibs along the ground, it does bounce up and down. So it does come off of the ground. And it goes up, it goes down, kind of like in a wave motion. Okay? But let's use the model of a traditional kickoff. And a traditional kickoff would mean that the ball is going to go up high and then eventually comes back down. All right? Look at that graph. Would that be linear? Is that one continuous straight line? Or is it nonlinear? Does it have a curve or break or something like that to it? All right? I hope you would say that that is a nonlinear graph. When the football starts on the ground, the height of the football from the ground is 0 because it's on the ground. As it goes up, the height would increase. And then as it comes back down to the ground, the height again would be 0. So in other words, for number 22, it is a non-linear function because the ball starts on the ground where the height is 0. The ball goes up, so the height would be greater than 0, then back down to the ground where the height, again, is 0. So that is a non-linear function. Pause your video, get all of that written down. All right, number 23. Aaron says that the graph that passes through -3, -3, -3, 0, and -3, 3 represents a linear function. Is she correct? Explain your answer. Now, you do not have to draw this, but I did to give us an understanding of what it looks like. So the points are at -3, 3, -3, 0, and -3, -3. Look at that purple line. The purple line is the graph. The gray lines are your axes. So the purple line is the graph. Is that a linear function? Well, it is one continuous straight line. It really is one continuous straight line. So it is linear. However, if you refer to your notes, the first page of your notes, we wrote up above the definition for a linear function that vertical lines are not a function. Vertical lines are not a function. If I did the vertical line test, if I drew a vertical line and put it over top of this graph, it would pass through every single point on the line, making it not a function. So is it linear? It sure is. But is it a function? No. So my final answer is no. The graph is not a linear function. The graph is not even a function because it is a vertical line. The graph represents a linear relation, but not a linear function. Pause your video and get all of that written down for question number 23. All right, so that is it for questions 22 and 23, and it's actually it for all of the linear and nonlinear functions worksheet. If you have any questions on the worksheet or the problems I just did, please do not hesitate to ask.